What's up, friends? Today we're back with episode 3 of the Raceboard series. In the last episode, we were able to go ahead and get all 20 of those inserts installed into the deck. A very annoying process. In the first episode, we got the mechanical setup done. That was all the drivetrain stuff. And in this episode, we're going to get the electronics setup. So I'll be making some adapters, plugging it all in, configuring the VESCs, and we should have a powered chassis by the end of this episode. If you've already seen this in person, you will know that that is successful, so stay tuned until the end to see how it turned out. So I filmed this next clip a little while ago when I was making the second part because I thought it was going to be one part, and I'm basically just talking about the electronics setup, so you'll get it. Next step, like I said, we're going to be doing the electronics of this. So the only electronics setup that I really need to do is create some adapters. So these tiny little Maker X ESCs use a smaller connector than usual, and so they provide that connector in their kit, but it doesn't hook up to the default size sensor connector. So I got some connector adapter things to solder onto those wires, and then we'll be able to connect those up to our motors. So we're going to make that right now, and then we're also going to make a XT90 to dual XT60 Y splitter for the power. And then I will decide how I'm going to work out the loop key for this build, because we will need one, and then I'll get back to you. But for now, let's work on making those adapters. Alright, so I got my connectors and stuff ready to solder. And these are the adapters that Maker X gives you in the bag. On here you can see that it goes 5 volt, temp, CBA, ground. However, connector plugs in this way, right? So that would make black the 5 volts, which makes no sense. So we're gonna switch the black and red wires real quick, and then we'll get ready to solder them onto the connectors that will go to the motor. And I took a picture of the pinout on the motor, and it should be a direct 1-to-1 matchup. So should be pretty easy. Alright, so I got the connectors repinned, so black is at the one end and red is the other. Technically I don't have to do that, but I just want it to match color wise. So now we're going to start soldering the connector, and I'm going to put up the pinout on the screen somewhere, maybe like here, just for reference. But this should be pretty simple. I'm using my smaller iron today, my TS80, because this is somewhat of a delicate soldering job. I don't want to pump too much heat into these connections and melt the connector. So first of all, we do have a receiving connector in here just so I can try to avoid melting stuff. And we're going to go ahead and use some flux on here and get that ready to be soldered. I'll run some flux across the pins here. Get them all ready to be soldered. There's a minute amount of solder on the pins of this connector already, or on the pins of on these wires already, rather. So all I'm going to do is clean up the soldering tip, add just a touch of solder, just enough, and then we're just going to touch the cable onto the pin, and solder it up just like that. So according to the pinout, we have ground, and then we're going to do green. Also, I should mention that I put some heat shrink onto these wires already, so as soon as they're soldered, I can slide it down and shrink it on. And then yellow is the next one. There's yellow. Then we're going to go blue. These three in the middle are the Hall sensor connectors, and technically they can be connected in whatever order, and when the ESC senses the Hall sensors, it will determine their placement. This one's maybe a little tricky. And then our last two are going to be temperature, which is white, and ground, or 5 volts, which is red. And then we'll do white. There we go. And finally red, 5 volts. There you go. Now do a quick pull test. Get the connector, little tug. Seems like it's good. Now we can go ahead and pull down the heat shrink tubing. Don't mind that the lengths are a little different. I'll go ahead and shrink that up. Being careful to not melt the connector. It's a very real thing that can happen here. There's that. And then we'll go ahead and slide this other piece of heat shrink down for good measure. And I think we're going to end this off with some hot glue around this and maybe some Captain tape, just because I want to make sure it's extra secure. So that's that. I'm going to do the second one now. All right, we got these 2 adapters soldered up. Now it is time to solder the XT60 pair to the XT90 that will be going to the battery. So let's get going. Alright, so just finished soldering it all up. So now we got our adapter and we got our other adapters. So we should be able to bring the board back and plug it all in. Alright guys, so everything is all soldered up now, and I spent quite a lot of time on this actually. I had to make some adapters and I tried really desperately to get this remote slash the iLogger to work, and I still have not been able to figure it out. It just isn't working no matter what I try, so I'm gonna have to resort to some forum help for feedback on that device, and I don't know why the setup isn't working. But anyway, I've got a Hoyt puck here, and I soldered a split PPM connector for it to go to these 2 ESCs. And if there's one thing about the Hoyt puck is that you'll know that it will always work because it's just a PPM remote. No fancy screen or anything like that, but we'll be using that to start off with, and then hopefully I'll be able to get this working after some troubleshooting. In any case, I've got the 2 sensor wire adapters hooked up. I've got the motors hooked up to the ESCs. I got the splitter hooked up here. So what we can do now is get the battery up here on the deck and do a test power on. We don't have our loop key set up yet, but the battery has an anti-spark plug on it already, so we can just plug this straight into the battery. And then I'm going to think for a little while about how I want to do the loop key. I may do a loop key riser in the back where it plugs in into the back. I think that would be a pretty decent solution. So yeah, I'm gonna put the battery up here and we'll do a first power on, and then I'll set up the desks. All right, so here, got everything set up, ready to be powered on. For safety's sake, I have taped up 2 phases on each of these ESCs to make sure they don't accidentally touch each other. And now we can just go ahead and plug this straight into the battery with the anti-spark connector. And there you go, both of these are now on. You can see the Hoyt puck receiver is on as well. And now what we can do is pull out a USB-C, not a USB-C, a USB-C cable, and plug these into the computer to get them configured. So that's gonna be our next step. I'm not gonna cover this section in this video. It's gonna make it super long. So I'll probably make a VESC setup video sometime later, but I really need to get this build further along. So we're gonna skip over that in the recording stage. All right, so after some consideration, I decided to go ahead and make the loop key wiring harness. So essentially, this is a really lazy solution, but it's temporary because the ESC I'm upgrading to in the future has a button. So this is going to sit here. We're going to run the loop key out and just have it stick up out of the enclosure. And that'll work for the time being, just to get it up and running. And then once we have the button, we'll probably go ahead and take this loop key out. So not ideal, but it'll work. We are now actually just about ready to stick the enclosure on and do a full test fit that way. So basically what I'm doing is putting in all these screws, which are M4 by 14. I did a test check and it seems like that's actually going to be plenty. And I'm making sure that all the holes are drilled in straight. Not that I can fix them, but just so that I know when I go around, if a screw looks like it's going in a little crooked, I can make sure to thread it into the threads properly. And this is actually good because some of these have a little bit of epoxy that's around the edge of the screw hole, which makes it harder to thread right in, like this one for example. So just pop off some of that epoxy there, and it should go right in there. Now that we have got all of the screws test fit in place, it looks good. So I'm going to go ahead and bring back the enclosure and set it down on the workbench area, fill it up with the battery and electronics, and then we'll try to go ahead and screw it all together. I think this is going to be pretty challenging because of how absolutely massive and long the enclosure is, but we're going to see. I went ahead and put in a little bit of insulating foam underneath the battery. I know that this particular kind does tend to compress a little bit over time, but the idea is just to provide a little bit of vibration protection from the enclosure itself, since it's made out of glass fiber. We got the fish paper underneath the battery, of course, but always good to have another layer. And I know for a fact that it would be quite noisy if I didn't have it. So there's that. Got the battery set in here. Now I do have the charge port wires at the front here that I need to figure out what to do with, but we'll get to that a little later. For the sides of the pack, I think I'm going to stick some foam in here just to make sure that it can't slide side to side. So I'm going to grab some of that right now and shove it in there. Alright, the battery is nice and tight in there now and should not be moving around at all. I'm going to put some padding around the BMS and then we'll start to move the electronics in. Alright, so I started laying the electronics in here, and it seems like there's going to be plenty of space, which is good because the ESC that we will be upgrading to is much bigger. So I marked out ESC1 and ESC2 and their respective phase cables on the motors, so when I hook them up later I will know which ESC is configured for which motor, because each motor is going to be slightly different values, so it's important to know. Now here we are going to need to put this in, but I think I'm going to put some foam in between this and the ESCs so it doesn't rattle around. I'm going to tape the Hoyt puck receiver to the side here with some double-sided tape. I'm doing my best to try and keep the receiver away from the power electronics, so it's placed way off to the side, and the rest of the power lead should be pretty far away from there. I haven't had any problems with interference from the power cables before, especially since, you know, the cables are running right across, but there's not really much you can do about that. So next, let's go ahead and plug in the harness for the ESCs. We got our anti-spark in here, and that's just going to sit here. This will plug into there, and then this red lead is what will be plugged by the loop key, and that will complete the circuit to the ESCs. So now we have to stick all the phase leads in here and make sure that they get plugged in correctly, but I'm just going to pull off some foam pieces to try and space out this harness a little bit. This is always that part of building where it's like finding the best way to finagle everything in your enclosure and still have it be functional. I'll probably end up having some smaller foam pieces in here to keep stuff from clattering against each other, but I'll do that once we put the actual enclosure on to the deck. But now I've got everything pretty much in about the right spot, so let's bring over the deck, lay it down on here, and see how things are looking. Here comes the deck. Just going to lay it down on top. And this is always one of those difficult parts of actually assembling your longboards, is you run into this problem where you have to put in screws from the bottom, but you also can't just hold it up with your hand because you're going to be trying to hold up the entire battery at the same time. So what I'm going to do now is plug in the wires here. I'm probably going to prop up the back side of the board a bit so I can actually see what I'm doing. Alright, so I've managed to stick everything in here. It's not so much a space problem as it is really just a wire organization problem. So now that we've got it all in there, I'm going to do a quick power on test, plug in the loop key, make sure it works, and then we'll move on to actually closing this thing up. Pretty exciting. So I'm starting to close this up, and I already know this is going to be so annoying when I have to open it again to switch the ESC, put in tracking, or my logger, all those kinds of things. All these screws, all these positions, yeah, it's gonna be tough, but hey, such is the life. I'm just trying to put in these 2 middle screws right now so we can flip the enclosure over and be able to see what I'm doing. Because right now it's pretty hard to line up the holes. Also, pretty hard to screw them in when the deck is sitting on top and not fully aligned, you know. I set it just straight back down onto the... Oh, that's not too bad. It is owing up to the strength of this enclosure because it is quite rigid. I'm just gonna sit down with it. And there you go. That wasn't as bad as I expected. Now I can actually properly line up the screw holes. There we go. Great. As you can see, there's some gap here. The motor wire routing is going to be interesting. It's going to be pretty tight back here, so see how this goes. Obviously, the front part of the enclosure is fitting better than the back because there's nothing keeping it from closing up. So I think we'll screw down the front first, and then we'll worry about aligning the back later. Alright, so y'all are probably wondering, how did we get to this point when the last thing you saw was me struggling to put on the enclosure? Well, I did some mining off camera, you know, and worked on the build a little bit. The enclosure had to have been one of the most infuriating things I've done in all, 5 years of doing E-skate now? Absolutely horrible. Putting 20 screws in, trying to get all those holes to line up with the inserts. Man, it was rough. And after all that, I still ended up with one insert that was like 1/8 of an inch off from one of the holes. I don't even know how that happened. It's making me mad thinking about it right now. But anyway, I got it all on there. That'll be fun to put on when I upgrade this. But here we are. We have a functioning build. And I went ahead and mounted up the wheels. I got my bearings from fasteddy.com. Really great service, super fast shipping, and really great prices. Specifically from there because I needed 22 outer diameter, 22 millimeter outer diameter, and 10 millimeter inner diameter, which is not a very common size. As most people know, it's normally a 22 millimeter outer diameter and 8 millimeter inner for a lot of skate bearings. I wish that these wheels had the 28 millimeter ones instead, but you know, I think they're still trying to be a street wheel, so I guess it makes sense. But anyway, I used the spacers that came with the trucks and ended up having to add 16 millimeters of spacer behind the wheel, which is including my custom mount spacer that adapts the Meepo hubs to the Board Dynamics gear drive. And then on the front here, I have just filled the leftover with whatever spacers I had. In the front, I had to just make the track width about the same as the back. So since the HD hangers have a wider track width, there ended up being more spacers on the outside than on the inside. But, you know, not a big deal. It's pretty easy. I don't know if that really needs to be covered any more than that, but we have this build here, and I have already turned it on and run the motors. Where's the loop key? Oh, it's in my pocket. I have already turned this on and run the motors to see how it sounds. It sounds absolutely wicked. So I'm just gonna plug this into my nice little janky loop key holder. And this is very temporary, by the way. Some people were like, isn't that gonna have problems? But yeah, it's just till I upgrade the ESC. These things are crazy. Sounds so raw. Pretty cool. I'm really excited to ride this thing and go for the first spin around the block. Now, one thing I did notice is people ask the question, why tubeless? And part of that is because they're supposed to be a lot more balanced. If you notice here, it's actually pretty hard for you to see on camera, but this tire is a bit unbalanced, so I'm not sure what happened there. I'm probably gonna deflate all 4 tires and try to seat them really nicely and then reinflate them. But anyway, this is the end of what I'm sure is a very long video, and for all of you that stayed the whole way, thank you so much for watching. Hopefully you enjoyed this assembly and just getting to see how this build comes together. This is far from the end of this build series. I have a lot of painting to do. There's going to be upgrades in the future, so make sure to stay tuned and get subscribed to see those future parts. But if you did go on to enjoy this video, thanks again for watching, and stay safe, keep on riding, and peace out. One thing I forgot to mention, I will be making a build thread for this entire build series on the Eastgate News forum, so if you want to chat with me there or see more details about the build, be sure to check that out. There will be a link in the description.